Hello, everyone. Welcome to Inventory Tweaks to Maximize Profits, New Approaches to Old Problems. Happy you're here. Wish we were in Vegas. Oh, it wasn't going to be Vegas. It was going to be Boston, so maybe it's better we're not in Boston. Anyway, I'm David Freese. I'm Chief Product Officer and CEO of Titan. I have Kurt Gutzmann with me, and today we're going to talk about how you can make more money with technology with some tweaks, meaning not huge ERP system level investments, but there's traditional problems you find in petroleum retailing. We have some new techniques, some new approaches, some new products. We want to share those with you, share with you how other folks have been making money. So with that, let me put our ugly mugs on the screen here. So again, I've been with Titan about 10 years. My main passion is chief product, but I'm also CEO and responsible for commercial and all the good stuff. I've been working with Kurt on and off for, I don't know, a million years, it seems like. Kurt, why don't you introduce yourself to the audience and give a little background?
Sure. Thank you, David. Yeah, David and I have been working forever, it appears, and I have a background in technology and engineering and applied mathematics. I've worked on a number of notable projects over the years, International Space Station, software engineering for that, the Great French Supercomputer Project, also known as ACRE, where I was manager of performance engineering and technology for high performance parallel systems. For the past 20 years, I've worked in machine learning and its applications to fraud detection in financial services, and also lately with Titan as the chief scientist here to provide a new leap forward in the application of analytics to wet stock management.
Thanks, Kurt. I would add that in early days, I was actually a real engineer as well. I termed myself a vintage AI. I was a knowledge engineer and architect on a project in 91 and 93 that was maybe the largest commercial implementation of a case-based reasoning system in the world at the time, but I went to the dark side and now I run a software company. So here we go. Let's talk about that software company, Titan Cloud. A lot of you know about us, but for those that don't, we're software only, not hardware, not a manufacturer, software only, SaaS, cloud for environmental compliance, wet stock management, otherwise known as inventory management, inventory reconciliation, as well as facility management. We were launched in 2012. I co-founded it as kind of coming out of another company that had some services basically in this space. We're in the Nashville area. We have a fairly large distribution of sites across the United States, North America, and some in overseas, 40,000, 120,000 tanks, probably connected to more ATGs than anyone else in the world, more VPNs, a fairly significant technology stack. We've been focusing on the largest C-stores and fleet owners, petroleum marketers for the time since I've been CEO, and that includes, I think, all of the top 5, maybe 12 of the top 20. You can see the names here of Circle K and 7-Eleven and EG Group and Speedway and Murphy, et cetera, et cetera. So we think we have a pretty good understanding of those needs, and our product decisions are always informed by how do we better serve our customers. The use cases, whatever your size, they're common. How to improve inventory management is common across the board. People have different approaches, but the way technology can improve that is pretty common. So let me just go to the next slide and talk a little bit about the state of the industry. Certainly in this world of the COVID and the pandemic, retailers are looking for ways to use technology to improve profitability. I think more than ever, having remote technology that you can use to manage your site, manage your inventory, having cloud-based software is a huge plus. So as we look at kind of what people are thinking, I think business intelligence and reporting are something that aligns with what we've been developing products around, as well as management of inventory and revenue. I think there's some very simple things you can do to improve profitability. One way that we think about it as we've talked to our customers and the different petroleum retailers is every fueling position is very important. So every fueling position needs to be in optimal shape. as well as you need to understand the sources of variance in your inventory, and that the equipment you're using has these built-in shortcomings and weaknesses that don't allow you to measure what's in your tanks the right way, or what's being dispensed, or what's being delivered. So we have a whole set of analytics around how to overcome those shortcomings, those weaknesses, those sources of error. And as we all say, it all starts with the tank chart. And Kurt's going to talk about how we've approached kind of innovating and making the tank chart depict reality versus some sort of geometrical ideal that it comes to the factory with. So I'm going to go to the next page, and Kurt's going to start talking about the tank chart.
Great. Thank you, David. Yeah, the tank chart. This is the source of all the problems that we ever encounter in wet stock management, mostly, not entirely. But you know, the tank, as it comes from the manufacturer, and the one you see here is a Xerxes ZCL. It's a very common installation. It's fiberglass, and it has hemispherical ends. So it's really a cylinder plus a sphere added together. And when you look at the catalog for it, you'll see that it's also ribbed. You notice the ribs on that thing sticking out there. And it's, of course, a dual layer kind of thing. But also inside, notice all the piping that's in there. You know, you've got various pipes, breathers, pumps, all kinds of things, the probes that go in there. And it's fiberglass, so when you pile dirt or gravel on top of it, it might flex or bend and become something different from an ideal capsule, which is a cylinder and a sphere. So the reality is that this thing only looks like something from our old analytical geometry books, which you might remember from high school that was torturing you. And there may be some tilt. The picture up at the top shows a little bit of a tilt that goes on there. Usually it's about 1 inch per the 10 feet or so, which is a typical tilt angle, maybe a little less, just to make sure stuff flows down to one end. Well, so all of these things basically make the analytical geometry that we work with to get these charts. And the chart, what is the chart? Well, the chart is the volume in the tank for a given height of the fluid in it, right? And the probe tells us what the height is. Of course, the probe itself might be having a bias one way or the other, but that's pretty easy to figure out. But there is a very hard problem, actually, to know exactly, to a very high degree of precision, exactly what is in there. Oh, and also they change size with temperature as well. If they're steel, they have a coefficient of expansion. Fiberglass also moves with temperature. So summer, winter, they may be different actual tanks in there, and they actually do vary quite a bit. So that may be another problem to think about too. So how do we figure this out? That's the real question, right? So if we just use the old analytical models, which are built into the gauges, or when they come from the factory with the strapping chart, as they call it, and sometimes the strapping charts are done empirically, where they add in, 100 gallons of water at a time and see how high it is. And then they give you a little table with maybe 20, 30 points on there. That's not going to really cut it either. That's not too good there. So how can we get this, right? That's the big question. And we can go to the next page, David. So we call it a chart, but really it's a function, right? There's, V equals F of H. H is the probe height. It's really the true height, not the one actually reported by the probe. And then we're often very interested in the differential of the thing. It's like, well, between these two heights, how much fuel is in there? So for example, measuring a fuel delivery, we would look at the height before and after, and that would be, the height that we have for the delivery. So we could get a volume off that. So, okay, that sounds okay. Now the resolution is limited by the probe, and it doesn't really matter, too much, but most of your probes are going to be somewhere between 300 to 1,000 parts per inch, okay? And in millimeters, you can see what the number is there, right? So the ability to resolve it is a big question. So how much can we really figure out in terms of volume differences is the question. So with our tank chart, we can detect about 4,000 microliters, okay? And that's the unit of measure we work with is the microliter. It's a cubic millimeter, in other words, or 1,000th of a gallon for a typical UST. So on the right-hand side, you see a chart, right? And it looks kind of like a real tank chart. Seems kind of smooth, but really the fine variation because of the internal geometry of the tank is reflected in that diagram you're looking at right there. And so these are tiny differences, but they all add up to a big difference over time when we're measuring the depletion cycles of the tank versus the totalizer changes in our dispensers. Ideally, those would add up correctly, you know. We would like say, hey, we sold 1,000 gallons and the tank chart says 1,000 gallons went out. That would be perfect. So that's the level of correctness that we're aiming for with the perfect gallon. We can go to the next chart now, page 7. So an important part of this is state detection. Well, what is the state of a tank, right? Well, they're idle, they're doing nothing. That doesn't mean the level in the tank isn't changing, but there's the pump is off is a better way to think of it, right? But even when they're idle, they can be changing volume because of changes in temperature. Okay, and there's a well-known volume correction factor that we use for figuring that out for both gasoline and diesel, but they're often based on an ostensible or, you know, given density of the fuel, which may not really be what is happening. We know the fuel density is different in the summer versus the winter in most places that have to do different mixes. So you'll have some errors even in the volume correction factors there. Plus there's noise in the probe. If a tank is installed somewhere where there's a busy highway or a railroad track nearby, or perhaps a waterway with a dam or something like that, you'll see a lot of seismic variation in the probe itself. So we need to be able to filter out noise from the probe in order to figure out really what is the height right now, even though it's moving up and down constantly. The next state the tank might be in is depleting. That is, the pump is on and things are going out of it. Somewhere, one of the dispensers or more is dispensing fuel. In our picture on the right there, the depletion cycles are shown in red, and the idles are shown in blue. And another one, which is very obvious, you know, because it's so abrupt, is the delivery. Whoosh, you know, 3,000 gallons comes in 2 minutes. You know, that's pretty obvious. That one's not hard to find. But to find these idles and these busies is important, right? Because that's how we can figure out how to build our tank chart. So state detection is an important thing. So we use methods from machine learning and computer vision in order to figure this out. It's, you know, how's it vision? Well, it's a one-dimensional world that we're working with in here, but it still has all of the same characteristics of 2D vision. So we can find out what the tank is doing at any point in time. And this gets a little more complicated with siphon-related systems, where we have two tanks connected by a siphon pipe, one being the passive tank and the other one the active one. So they have an extra state, which is not idle, but is what we call idle relaxing. So the pump is off, but fuel is flowing from the passive tank through the siphon into the active tank, raising its level, so they are both trying to equilibrate. So you could have idle equilibrated, nothing's happening, or idle relaxing, there's fluid moving between the two. And this also occurs while a depletion's happening, and that is also a complicating factor when you try to construct the tank chart for a siphon system. So what are all these things that we can get once we have state detection? Well, we can do automatic meter mapping, find out, you know, which meter corresponds to which product. Okay, that's important to know. We can do inventory reconciliations, what we call counting interval recon. And we can do delivery recons. We can find out what the delivery really was with the excellent tank chart versus what the bill of lading says. We can even apply it to meter drift determinations and leak detection. And finally, there's another set in here of anomalies. So there can be small anomalies or large anomalies. Those are the kinds of things we can find with this tank chart. And deliveries are the last problem I'll talk about here. They're always a source of frustration for people, you know. They say, oh, you know, the truck went here, it went there. Oh, it was a split load. Part of it went here, part of it went someplace else. Well, we can measure the delivery very accurately because, you know, the probe rises quickly. And then there's another hard problem out here, which is the sloshing that occurs after the delivery that has been completed. And that sloshing, depending on the tank and the configuration and all this kind of stuff, could go on for 30 minutes, even an hour. And so the probe will be wobbling around. And at the meantime, transactions are occurring and there are depletions being pumped out at the same time. So how do you really figure out the maximum probe height achieved and account for the sales that occurred during the delivery? So as we say, you know, sloshing is a baffling problem. So that can be figured out as well when we have the models for the settling of the tank and returning to an equilibrium state where it's not moving around as much. So an example here from one of our clients shows the bill of lading. These are temperature compensated amounts here. And in liters, okay, in case you're wondering, they look kind of big for gallons. So these are some BOL numbers in temperature compensated liters, and you see the calculated amount from our tank chart, and you'll see that they are very, very close. The worst one is off by 30 liters out of 9,000 liter delivery. And the best one is almost right on at 2.6. So not too bad, number 10 there. So this is the level of accuracy we're able to obtain with the perfect delivery based on our tank chart. This is great because you don't have to enter the BOL manually or make mistakes and all that kind of stuff. And even if the BOL did come in and say it was 9,000 and we said it was 5,000, well, it's really obvious you had a split delivery. So these are some of the things that we can optimize your operations with the perfect delivery as well. David?
All right. Thank you, Kurt. So what can you do with all this latest and greatest tank charting and state detection? Again, we're going from analytical geometry to finite element modeling and state detection using machine learning. So here's, we're going to go through the next few pages, talk about some of the new things, the new approaches to old problems. So one is the reconciliation, and we have this analysis called accounting interval reconciliation or AIR, but let's kind of compare it to what you're used to, kind of the old ways of doing things. We have statistical inventory reconciliation, or SIR, which was in the early 80s by Warren Rogers, developed, kind of a focus on leak detection, really kind of a process control kind of analytics. It's now considered a deprecated method for leak detection, at least in the United States, as people are using interstitial sensors or CSLD. Some of the legacy, older wet stock and inventory management firms still use it, but they're just kind of collecting it in a more high frequency manner. So it's kind of the oldest way of doing things. People may be putting a little more frequent data collection on it, but it has a significant amount of problems with that. Move to the middle, which is business inventory reconciliation. So not really leak detection at all, but focusing on accounting. So, looking at what I started with, what was delivered, what was sold, what am I ending with, it's kind of an early version of wet stock management, if you will. And I think that it's good from an accounting perspective, but many times it doesn't have the better tank chart. It uses the ATG's tank chart, which Kurt went through the issues and the weaknesses of that. And again, requires typically special hardware as well. So the latest iteration here, the accounting interval reconciliation, or AIR, is improving on both SIR and BIR. Doesn't require any special equipment, allows us to create the tank chart, allows us to do the reconciliation. So we can apply a lot of innovations to that. Leak detection, the 0.025 gallons per hour. We already talked about the perfect delivery and the level of accuracy there. So you can provide this to your fuel accounting department, to your compliance team, whoever cares about making sure that you're getting what you bought and you're dispensing what you delivered. AIR is a way of doing that. Another kind of broader, going up a level, these innovations, these kind of, new ways of doing things. We have a product called Perfect Gallon, and I just want to talk about today. We've been talking about pieces of it, but really at a high level, how do I minimize my inventory variance, or my financial a gallon from the terminal equals my physical gallon delivered, the perfect delivery equals what was dispensed, understanding that meters are drifting equals the financial gallon in the point of sale. So our customers are focusing on a variety of areas of where they can make money on this. One is the inventory reconciliation costs, where I'm reducing the failure rate, the dispatches to go fix something when it's failing, and just in general, by injecting additional automation into this process, scales your organization. Another area is delivery shorts. While I don't think anybody thinks their carriers are trying to steal from them, you want to have a situation where you can, reconcile immediately. Here's what was physically put into the tank. Here's the delivered BOL. I know that in your real-time fashion, and I can close the whole financial transaction with a high degree of accuracy and certainty. And then the third area is meter drift. The meters are stealing fuel. Happens all the time. Even with the new meter, even these new fancy meters, you still need to understand what's happening with your meters and if they're drifting over time. Our analytics actually determine the meter drift as part of the essentially setup process. So these are, again, we talked about AIR as innovation, something new. This perfect gallon related to variance. We have some new ways of thinking about things. But why is it new? What's different about it? You know, it's not just marketing here. There's actually some new technology behind it all. So cloud computing scale, so we don't require equipment. We have this kind of unlimited cloud computing capabilities, and we can contemporaneously sample probe heights and totalizers several times, you know, almost every second. Gives us a data stream of kind of the quality that really can't really be matched. The other part of this related to cloud computing is just the computationally intensive algorithms, stuff that you could never imagine using 20 or 30 years ago, you can now apply to solving for tank charts or anomaly detection or classification. I mean, this is kind of one of the things, like, you know, you can't possibly put this into an ATG, it just doesn't work. And now you kind of open up, you know, again, machine learning and artificial intelligence have been around for decades, maybe since the late 50s, but the compute power to really act on that is relatively new, and now we have the data streams to go with it. Then the final ingredient is this enterprise software platform where you do more than just notify people of problems, but you can sort of look at the problems, you can manage them, you can do root cause analysis, you can dispatch somebody to fix them, so you can manage a business process of inventory management, inventory reconciliation, wet stock, as opposed to doing dashboards and reports, which are useful but not nearly sufficient. So again, something new. There's some underlying technology trends that are new and different that kind of give rise to what we're doing here with Perfect Gallon, with how we're tweaking your inventory management process. A couple more slides. You know, as we look across our customers, we can kind of categorize their current approach in kind of this maturity model, inventory variance management maturity model. So you can tell I used to be a consultant, but you start at the very least with the accounting system, which has daily over, short reporting, probably no workflow. If you're using the ATG's tank chart, limited physical delivery, you might be using VOL. This is kind of what you have. You might have PDI or something like that. It's better than nothing. You go to the next level of the SIR, BIR, BVR, where you're getting the same daily over short reporting, but you're getting physical delivery data, and it's sometimes adjusted for sales that are happening at the same time, so you get a better adjusted delivery. You move to our first level of product called Perfect Gallon Standard Definition, which takes what you have with BIR and SIR and BVR and goes into the more advanced workflow, better reporting, better reconciliation processing, and then the final kind of iteration, if you will, is our Perfect Gallon High Definition, which is where you get this fine-grained tank chart, the signal processing required to do perfect delivery, anomaly detection using air. So this is kind of this range of where you're at. And each step change, you can gain significant ROI and make more money without a lot. You're just changing, you're just tweaking your process, you're just injecting more technology into it. Doesn't require many moving parts from a customer's perspective, but it yields tremendous results. And one of the applications of Perfect Gallon High Definition and machine learning in general is anomaly detection and leaks. Coming back to compliance in the heritage of Titan, leaks are a very interesting use case around anomaly detection. So I'm going to turn it back over to Kurt, and he's going to talk about how we've applied this to leak detection and what the results are so far.
Thank you, David. So we have a couple of graphs here. This is a result, and we have many, many more, but this is just one of them, for a leak detection using the National Working Group on Leak Detection Evaluations leak detection protocol for continuous in-tank leak detection, sometimes called SITLIDs. So that methodology says, let's get a tank system and simulate its operations. And sometimes we'll just let it run as if it were tight, right? The goes ins equals the goes outs, right? Maybe with some drift on the meters. And let's also now introduce some synthetic leaks into that simulation or trace, basically. This is called leak injection or leak induction into the simulation of the tank operation. And this is done many, many, many times, thousands of times, right? So from there, we can obtain the probability of detecting the leak and the time required to detect the leak, okay? So you work with the standard leak sizes that David noted earlier, But here we have a smaller leak at 0.025 gallon per leak. This is a little one, but also something we need to find out about. And so these little histogram on the left shows the count and the time to detect the leak that you see there. Okay, so it's like, okay, the worst case was 200 hours. One case we found it in 6 hours. Okay, but the expected time is somewhere in that middle, around 40 to 60 hours for a tiny leak like that, which is about 2 days or so. Not so bad. Normally it would take you weeks and weeks to figure this out. Also important though is this graph on the right. So if you didn't do anything, that would be the orange line. It just keeps on leaking. Okay, and then the gallons add up. So you see at 48 hours, we've got a little more than 1 gallon lost here. At 120 hours, it's up to 3. Okay, and it just keeps on going, right? And that's not so good. So what we find with our evaluation protocol here is that we can show what the probability of detecting the leak is as a function of time. Okay, so that's that upper sort of teal colored line, right? The probability that the leak is detected. You see it rises up to almost 100% around 192 or 200 hours, but even a 50-50 chance at around 48 hours. So that's very good right there. And because of that, we can then produce the expected value of the detected leakage and what the undetected leakage was. And so that is why you see that line curving off very quickly at around 1.5 gallons. That's the important point. We can find a tiny leak in an amount of time such that the expected leakage is about 1.6 gallons. So that's the kind of thing we can achieve with a better tank chart. David?
Thank you, Kurt. So just to understand that this is kind of a 10x improvement of what you have today in the marketplace. So most the standards are 0.2, not 0.025. And then the time to detect is also, it's weeks. So it's many days. So by improving both the detection and the time to detect, you get a kind of a step change in what that means. And that just, plays into the fact that, underlying all of it is the better tank chart. It gives you the basis to do this. So let me end our conversation, just say, hey, people are making money doing this, kind of get back to why we're here, maximizing profits. So we can dramatically reduce your inventory variance probably by 80 to 90%. We can reduce your delivery variances by at least 80%. We can improve your fuel sales and your profits by more than 3% per site, which, depending on your operating characteristics, is millions of dollars. We have lots of proof points. And I think, again, getting back to why we're here, there's not new technology here. This is stuff you already have on your site. It's just, we might even be connected to your ATGs already. I don't know, you might be a customer, but we're just getting the data that you already have, and we're applying new technologies to it so that the implementation cost is almost zero. Again, the implementation cost is almost zero. In fact, it will be zero. If you sign up for it, you use it, you get value out of it. It's a very simple proposition. All right, and final slide is if you want to get in touch with myself or Kurt, here's our emails, titancloud.com. And again, thanks for joining us today on this, I don't know what you'll call it, webinar, remote, virtual. Look forward to seeing folks in person at some point soon. And I will tell you that down here in Nashville, it's been a pretty good place to be in the middle of it all, and things are pretty open. So if folks want to come visit us, we're in a new office. Again, thank you very much. Thank you, Kurt.
Thank you, David. Thank you, everyone.
Bye-bye.